Hello everyone, I am Demet Kayabaşı and this is our talk titled The Causative-Inchoative Alternation in Turkish Sign Language and the Age of Acquisition Effects on Complex Clauses. The layout of our talk will proceed as the following. Firstly, we will talk about what the causative-inchoative alternation is and how it manifests itself in signed and spoken languages. Then we will briefly talk about serial verb constructions, which we have called complex clauses in this talk for the sake of simplicity. Then we will briefly go over the age of acquisition effects observed in the sign language acquisition literature. Afterwards, we will explain how we collected and analyzed our data. And lastly, we will describe our results and discuss their implications within the existing literature. So the causative-inchoative alternation refers to verbs that can be used both transitively and intransitively. Some languages like English do not mark this alternation morphosyntactically. As can be seen in example 1, the verb break is transitive in 1a and intransitive in 1b, yet the morphological form of the verb stays the same. These kind of verbs are called labile verbs. English also employs analytical causatives like in to. In 2a, the causation event is expressed via the verb cause, and the change of state of this causation is expressed via the verb die. But in 2b, the verb kill has both of these components as it is a lexical causative. Analytical causatives can also be formed with an auxiliary, like make, as can be seen in 2c. Some other languages, like Turkish for example, mark these valency alternations morphosyntactically. In 3a, the verb düş, fall, is intransitive, and in 3b, the causative morpheme is added to this verb to mark the valency increasing operation. It is also possible to mark a valency decreasing operation in Turkish. In 4a, the verb aç, open, is a lexical causative, which means it denotes a causing event in its meaning despite that it doesn't have causative morphology on it. In 4b, a middle voice morpheme is added to this verb to mark the valency decreasing operation. Sign languages employ all of these strategies as well. In 5, we see an example of a labile verb in Danish Sign Language. The verb break in both the causative and the inchoative clause has the same hand shape and movement. We must note that some labile verbs in sign languages might have lexicalized from handling hand shapes, a process that neutralizes the handling component and allows the given hand shape to be used in intransitive contexts as well, as mentioned in Benedicto Imbrentari 2004 and Engberg Pedersen 2010. In 6, we see an example from American Sign Language, where the causative and inchoative clauses are morphosyntactically marked, which surfaces as different hand shapes. In 6a, the causative clause has a handling hand shape, whereas in 6b, the inchoative clause has a whole entity hand shape as its predicate. Benedicto Imbrentari 2004 account for this by suggesting that different functional heads that introduce the internal and external arguments host different hand shapes. The functional head F2 introduces the internal argument and hosts the whole entity hand shape. The functional head F1 introduces the external argument and hosts the handling hand shape. Therefore, a causative clause consists of F1 dominating F2, whereas an inchoative clause consists of an F2 projection only. This account also makes the implication that all transitive clauses can host handling hand shape classifiers only. As for the F1 projection in intransitive clauses with an agent, also known as anergative clauses, Benedicto and Imbrentari argue these host body part classifier hand shapes. Contra Benedicto and Imbrentari, Kimmelman 2018 observes whole entity classifiers in transitive clauses as can be seen in 9a. But in this clause, the argument that surfaces within the whole entity classifier is the internal argument. And he notes that this is not possible with every predicate anyway, as can be seen in 9b and 9c. Tang and Yang also make an observation contra Benedicto and Imbrentari in 10, where the causer is an inanimate entity, the wind, and the clause is naturally transitive. Lastly, sign languages also employ analytical causatives like in 11 in Danish Sign Language, using the verbs make or change in this case. Greek Sign Language and Catalan Sign Language are also reported to use analytical causatives. We will discuss all these ways to mark causatives and the causative-inchoative alternation in Turkish Sign Language data in the results section. Moving on to the serial verb constructions, firstly we would like to clarify what we call serial verb constructions because multipredicative constructions as such are often also categorized under the umbrella of resultatives. And there seems to be no clear consensus for this distinction. 12a here is given as an example of a resultative. Note that the adjectival predicate clean marks the resultant state in this clause. In 12b, what we see is a multi-predicate monoclausal structure where two verbal elements coexist to mark the causation and the process or change of state of the same event. What we consider as a serial verb construction in our data aligns with 12b. Now let's see if we can also distinguish this in a sign language. Tang and Yang note that there is no consensus as to whether these multi-predictive structures should be categorized as serial verb constructions or resultatives, and they choose to mention them as resultatives in their paper. In 13a, they describe what expresses the resultant state as a size and shape classifier, length in objects. And based on the translation of this clause, we deduce that this is probably an adjectival item, as opposed to 13b. In 13b, the item that marks the resultant state of the given event is a verbal classifier that shares the internal argument with the preceding verbal classifier punch. What we consider as a serial verb construction in our data aligns with 13b in this case. And we call these constructions complex clauses because they are syntactically complex and they might possibly have embedding. Lastly, we can note that regardless of what morphological marking they bear or don't bear, both causatives and inchoatives are considered to be complex regarding their event structures by Talmy and Tang and Yang, among others, for they include multiple sub-events. Moving on to the age of acquisition effects, several previous studies have shown that the age of acquisition impact both comprehension and production not only in childhood but also in adulthood. Moreover, morphosyntactically complex structures such as classifiers are observed to be acquired in the later stages in language development, even in cases where the child gets exposed to the sign language in question from birth on. Moreover, Sevgi 2019 showed that subject and object dropping in classifier constructions in Turkish Sign Language is age-sensitive. Therefore, we hypothesize that means of marking the causative-inchoative alternation and producing serial verb constructions that occur in both causative and inchoative clauses may be an age-sensitive phenomena. To collect causative-inchoative alternating clauses and to test our hypothesis on age sensitivity, we designed a picture description task. We were able to reach 24 participants, half of which got exposed to Turkish Sign Language from birth on, and the remaining half getting exposed to Turkish Sign Language after the age of 4. Most of the late acquisition group have reported getting exposed to Turkish Sign Language around the age 7 or 8, yet a few reported their exposure age as low as 4. The consent forms were explained and the picture description tasks were run by our dev consultant. We used 17 stimuli to elicit causative clauses and 17 stimuli to elicit their inchoative counterparts. This is an example of a causative-inchoative pair, bounds. The causative stimuli and the inchoative stimuli were shown as separate tasks and not as alternating pairs. We prepared another set of stimuli to elicit accidental, non-volitional causatives and inanimate causers. Lastly, we prepared a fourth set of stimuli to elicit causation events in which there is no direct contact in the causation. We annotated the recordings in Elan software and then moved them to Excel to mark the utterances produced for the dependent variables, such as the type of the first or the main predicate, classifier or lexical, and whether the utterance is a complex clause, in other words, a serial verb construction. We also noted the lexical meaning of the predicates and the subtype of the classifier in the case of classifier predicates. Then we arranged the data frame for RStudio, adding the independent variables such as the acquisition group, structure type, and the stimuli to which they responded. Based on this data frame, we calculated the alternation types in RStudio. Basically, if both the causative and inchoative counterparts of a stimuli was signed via a classifier, then this instance was marked as a classifier alternation. If both counterparts were signed with a lexical verb, that instance was marked as a labile alternation. If either one of the stimuli was signed via a lexical verb and its alternating counterpart via a classifier, then this instance was marked as a mixed alternation. We will talk about the distribution of preferred alternation strategies by different age of acquisition groups at the end of the talk. But firstly, let us move on to describe our findings on how this alternation manifests itself in Turkish Sign Language. Turkish Sign Language employs all three strategies we have previously seen: labile verbs, classifiers, and analytical causatives. In 14a here, we see a causative clause with the same handshape for the verb break as we saw earlier for Danish Sign Language. One might argue that this was a handling classifier handshape, but just like in Danish Sign Language example, the inchoative counterpart of this clause also conveys the same handshape. As we noted before, this might be a lexicalization from a handling classifier indeed. But we argue that the handling handshape no longer has its handling component. For the handshape, the same handshape can be used in the metaphorical meaning of break, as can be seen in 15 here. To break one's heart. Thus we consider example 14 an instance of labile alternation. Turkish Sign Language also employs a handling classifier whole entity classifier alternation in line with Benedicto and Brentari. 16a here shows a causative event of opening a door with a handling classifier. And 16b, its inchoative counterpart, manifests itself with a whole entity handshape. (17a) shows another instance of a causative, but in this case the causing event does not require grabbing, but it only requires contact, as can be seen from the handshape. Thus, we suggest that handling classifiers have subtypes as grabbing handling, like in 16a in the opening a door example, or contact handling, like in 17a here. A similar proposal for American Sign Language was done by Supula 1968. 17b, the inchoative counterpart of 17a, manifests itself as a whole entity handshape again. So far we have only seen human causers. 18 showcases a causative with an animal causer, and the causative verb surfaces as a body part classifier. This goes against Benedicto and Brentari's observations, where they suggested that the external argument in unergative clauses surface as a body part classifier, and since 18 has an internal argument as well as an external argument, then this goes against their account. Here we suggest that the external argument of a transitive clause can surface both as a body part classifier and a handling classifier, but the handling classifier handshape specifically requires a human causer. In 19, we see another event of causation with an inanimate causer, much like the Tang and Yang's example in 10. The verbal classifier here surfaces as a whole entity classifier. However, we are not entirely sure that this clause is a causative, as in the wind is bending the palm tree, and not an inchoative with a reason clause, as in the palm tree bends because of the wind. This was an utterance given to a causative stimuli, but more clauses with potential inanimate causers must be tested out to be certain. If, however, the case here is that the clause is indeed a causative, like the one in example 10, then this would also posit counter-evidence to Benedicto and Brentari's account. Moreover, example 20 shows an utterance with a human causer, and the causing event bump into surfaces with a whole entity classifier. Judging by the lexical meaning of bump into and the shown stimulus, we can say that the causation event here is not volitional but accidental. Therefore, we suggest that the handling classifier handshape may have to do with volition instead of transitivity. Lastly, 21 exemplifies what appears to be an analytical causative, with the verb change employed as a causative auxiliary, much like the one we saw earlier in 11 in Danish Sign Language. However, we must also note that the same stimulus has been described by a causative clause without the verb change and as a serial verb instead, here in 22. This suggests that multiple ways of marking causatives and the causative-inchoative alternation are possible and acceptable, and in fact, we will see that both inchoative and causative clauses can be constructed as serial verb constructions, which indicate that inchoative clauses also express complex events just like their causative counterparts, meaning that they consist of more than one sub-event, and these sub-events can be expressed overtly. These serial verb structures occur both with causative clauses like here in 23, where the second predicate is a lexical verb, or in clauses like 24, where the second predicate is a classifier. Note that in 23, the causation surfaces through a grabbing handling classifier. 23 goes against Teng and Yang's observation that telic causal events expressed with an handling classifier cannot be followed by what they consider a resultant state in Hong Kong Sign Language, and their explanation is that this is because the manner of the causing event is already encoded in the handling classifier handshape. Therefore, we can say that there is cross-linguistic variation regarding this phenomena. In short, both 23 and 24 show that subtypes of handling classifiers that denote causal events can be followed by a serial verb that marks the change of state sub-event. Lastly, 25 shows us that serial verb constructions can also occur with inchoative clauses, as in this example, the glass breaks by itself, there is no causer. Therefore, this shows us that both causative and inchoative clauses are event structure-wise complex, which is also in line with Tell Me 2000 and Lewis 2017. Now that we have described how the causative-inchoative alternation manifests itself in Turkish Sign Language, different types of causatives in Turkish Sign Language, and serial verb constructions that occur with both sides of this alternation, let us move on to take a look at whether preferring a certain alternation strategy or producing complex clauses, in this case serial verb constructions, are age of acquisition sensitive phenomena, as we hypothesized earlier. Figure 1 shows the number of instances of which different age of acquisition groups preferred either one of these strategies of labile alternation, classifier alternation, or mixing using both. Both age of acquisition groups seem to employ both of these strategies and also a mix of them, with no significant difference in the number of instances. However, to be able to see if any of these alternation strategies can be considered an early acquisition phenomenon clearly, we divided the number of instances of each alternation strategy produced by the early acquisition group and divided this to the total number of instances of each alternation strategy produced. As the intersecting standard error lines in Figure 2 show, none of these strategies seem to be an age-sensitive phenomenon. However, to reach a certainty in this matter, more studies with more participants are needed. Let us now see if the production of serial verb constructions, dubbed as complex clauses here, with causatives and inchoatives is age-sensitive or not. Figure 3 shows the average complex clauses produced by each age of acquisition group for both causative and inchoative clauses. Expectedly, there are more complex clauses produced for the causative stimuli as opposed to the inchoative stimuli. And the standard error lines, especially in the causative section, seem to indicate a significant difference among the two age of acquisition groups. To clarify whether the difference is indeed significant or not, we fitted this data to a Bernoulli model with two predictors, age of acquisition and clause structure. Each predictor has two settings. The age of acquisition predictor is either early or late, and the clause structure predictor is either causative or incohative. 0 on the X scale refers to simplex and 1 refers to complex. The intercept is the overall mean of the posterior possibility of complexity given the predictor settings of early acquisition and incohative clauses. The size of the effect is measured by the distance between the vertical line and 0. The intercept then supports figure 3 in showing that early acquisition group has mostly produced simplex clauses for incohetives. To compare the intercept with the other predictor settings, we take the effect size of the setting, so how close it is to 0, and add it to the intercept, rightwards towards 1 if the effect is above 0, and leftwards if the effect is below 0. The effect shown in the second row, right below the intercept, has the settings of incohetive, just like the intercept, but the age of acquisition setting is shifted to late learners. When we take the effect size and add it leftwards to the intercept, the model shows us that the late acquisition group produces a greater number of simplex sentences for incohetives in comparison with the early acquisition group. Now, let's change the clause type setting to causative and the age of acquisition setting back to early learner. The effect in the third row is above 0, and added to the intercept, it shows that the early acquisition group produces predominantly complex clauses for causatives. This also backs up what figure 3 shows. Now let's compare this effect to our fourth and last effect with the age of acquisition setting changed to late learner. The last effect is just below 0, and added to the intercept remains below 0, which shows that the late acquisition group produces more simplex clauses than complex clauses for the causative stimuli, and the difference in the effect sizes of the two age of acquisition groups is indeed significant. Figure 4 is our model with random effects excluded, which means that the model disregards any potential participant deviations. Figure 5 shows a slightly different picture once the random effects are included in the model. This difference shows us that the participant deviation is high, which is expected given that we have to work with a limited number of participants, a common obstacle in the research of minority languages, as stated by Lieberman and Mabry 2015 as well. To conclude our findings, the causative-inchoative alternation in Turkish Sign Language manifests itself in the form of labile lexical alternation and classifier alternation, and a mix of these strategies is possible. Preferring one alternation strategy to another is not an age-sensitive phenomenon. Both incohetive and causative clauses seem to be complex in their event structure. Producing complex clauses, so serial verb constructions, seems to be an age-sensitive phenomenon. And as the next step of our study, the analysis of an acceptability judgment task for serial verb constructions to determine whether they are biclausal or monoclausal will follow. This study has been funded and supported by Boğaziçi Araştırma Project, supporting sign language development of deaf children with hearing parents through linguistically informed preschool stories. P.I. Kadir Gökgöz. These are our selected references. Thank you all for your time. We would appreciate your comments, questions, and suggestions.